Okay, so for the second question, x is uniform in a to b and y equals to x squared. So from this, we know that the plot of x in the x-axis and y in the y-axis should be like this. X squared is a parabola, and so first we want to find fx. And we know that x is uniform in a to b, so the sum of the probability from a to b equals to 1. So on every point, it should be 1 over b minus a. The from a to b, the probability are equally the same. So from a to b, the probability is 1 over b minus a, and for x smaller than a and b x greater than b, they should be 0. And so for then we need to find fx, and it is easy to think like find the integral of fx, smaller fx. So here it should be x minus a, and this is my I didn't change that, but it should be x minus a. So it's like 1 over b minus a times x from a to b, and when we plug in a to b, then it should be b minus a over x minus a. And for x smaller than a, it should be 0 from the plot. And if b is greater, x equals to b, greater than b, it should be 1. Yeah. So for the second part, it should be when a equals to -1, b equals to 3, find fy and big Fy and expected value of y. So first we find smaller Fy. When we plug in -1, I draw a graph and it should be like this. The value of y, it's from 0 to 9, and the value of x is from -1 to 3. And we can see that if x is between -1 to 1, if the value of y is between 0 to 1, the x value can be from -1 to 1. So when we plug in, it should be like y equals to x squared and x equals to plus or minus the square root of y. And the derivative of y should be -2 the square root of y, or 2 times the square root of y. So we need to consider two cases. When y is between 0 and 1, that means that we can have this part and also have this part. So we need to consider both cases and get the fy equals to 1 over 4, which is fx. Yeah, because we're told that a equals to -1, b equals to 3. So 3 minus -1 equals to 4, and 1 over 4 is fx. So it's fx is here, and the derivative of y in absolute value should be 2 parts. And when we plug them together, we get 1 over 4 times square root of y. This is the case when y is between 0 and 1, and there's another case when y is greater or equal to 1 and smaller than 9. So in this case, there's only one situation, because from here 1 to from here 1 to 9, x can only be positive. So similarly use the same equation to find smaller y, and it's 1/8 times square root of y. And then I plug, and then I draw the graph. And so from y equals to 0 to 1, it's this part, and 1 to 9 is this part, and 0 otherwise. And try to find big F y. It's take the integral of this two parts, and I just like it's a more like a math problem here. So it's like find the integral of 0 to 1 of 1/4 times square root of y, plus find the integral of 1 to 9 times 1/8 to 8 times square root of y, and then we'll get this. And for the last part, to find the expected value of y, it should be the y times fy. So we know that there are two parts. So for the first part, it should be y times this function, and the second part should be y times this function. And to sum them together, we get the expected value of y, which is 7/3.